Yeah. I got it.
Alright, cool.
Awesome.
Thank you.
So if you want these, whatever you like. Switch each other up, different names.
I'll be Joe today.
You could scratch out Joe and put Alice if you want.
No one will be able to tell the difference.
Okay, so before we begin, if anybody needs passport stuff, see me or stop here after the presentation. Need that. How are we doing? Integrity launched? Okay. You know the song?
Which one?
Adam Sandler sang that song a while
I went to permit so that
Yeah. Let's put it on stage. Yeah, this is what I think about when I think about your topic. Yeah. Well, they call it cash bunkers. Professor Scott, pizza. Were you here for the text mining one?
Oh, really?
Yeah, it'll take a moment. It's just not going too smooth. How many? $68,000.
Was.
Okay. Somebody opened one with 300,000.
Yeah, it'll take a minute. Like that when you give us for class, you can stop everyone's computers.
Yeah.
It was fun.
Mission accomplished.
I talked about that later real fast. Doubt it.
Oh, I gotta be a blue one.
We'll be over there.
That's
72.
We'll be over there.
boys
Got
are
it.
back.
Then you've got to click on the enable.
Yeah, no, that's what it's doing right now.
Oh, it's okay.
So I don't drive to make apples to my car, but it's not that. So you're done. Already got the whole thing.
I don't know.
I don't go to Victoria's. I'm gonna drive Jake's car after my car thing.
Excel good to go?
Yeah.
Table content and all that stuff.
Everything's up.
Okay.
There we go. Sound all. We didn't figure that out yesterday. You're using it individually.
So welcome to another analytics presentation. Some familiar faces here, some newcomers. Today we're doing all analytics presentations in this room. After this one there'll be a break for lunch, and then at 1 o'clock we'll start up again. We have a presentation on can you predict whether a person is male or female based on how they write on Facebook? Without reading a single comment, can we come up with some math techniques to do that? Then we've got another one predicting Airbnb bookings. And then we have one on breast cancer. Are there any variables and information we can get from breast cancer studies to help with patients and things like that? So that'll be this afternoon. Today we've got a nice fun one here. How much is your car worth? So I won't steal the show, but they're going to look at some stuff here. Got all juniors in here today looking to continue on with the business intelligence program next year. I don't know what they're thinking, because it's 10 times the amount of work they're used to.
It's all right.
Just kidding. So I'm Professor Tychik. I teach at the business faculty department, and I teach the final 3 classes in the PI program. Right here, I got some information if you're so interested as well. So the show is yours.
As Professor Tychik just mentioned, our project is How Much Is Your Car Worth? I'm Garrett Grunke, this is Sean Butcher, and that's Joe Cleve. So we were tasked with figuring out a model that would predict how much your car is worth on a resale market. We got 350,000 observations of data, and we had to cut that down to make our model so it was a better model for you guys so we could present it. And by that, how we did that was we took out cars such as limousines, because who's buying limousines? Not many people. As well as we took out the lowest 10% of prices on these cars and the top 10% of prices on these cars to make the model more compact and more suitable for what we're doing. And our model is a multilinear regression which only allows up to 16 variables. And when we were doing our project, we had over 70 variables total. So we had to figure out which variables were the most important and what we thought people look at the most when buying a used car.
So to give you guys a little bit more information as to why we did what we did, we got a little quote for you. It says, "The goal is to turn data into information and information into insight." Now what this is as data analysts, what you want to do is turn past trends in data into information and being able to create knowledge out of it. So that's kind of what we did with our model, is we took past trends and past different information and data sets and put them into a user-friendly model that we can use and to predict prices to forecast for the future. Now that allows us pretty much to help with more precision. However, no data set will ever be able to be forecasted 100%. If it was, things like the lottery, sports, none of that would exist. So this is the closest we could get to it by using forecasting models. And one we did today was for multilinear regression, which we'll get into a little later. So obviously, there's 2 different types of ways to purchase a car. You could buy it new or you could buy it used. When you're purchasing a new car, you don't really have to worry about its past because it doesn't really have a past. All you got to worry about is what features you want. When purchasing a used car, there's a lot of different variables you got to consider. So if you guys were to be purchasing a new car right now, what are some variables, different things that you would look at when purchasing that car? If you have anything, you can either just raise your hand or shout it out.
Miles on the car?
Miles, absolutely.
Customer satisfaction.
So like past, maybe like reviews.
Mm-hmm.
Okay. Anyone else?
Number of cup holders?
Cup holders? Just in case you got a big family, you want to feed them in the car. Okay.
Size of the cup holder is kind of told as 20 ounce pound.
For you, that's very important. Anyone else?
Heated seats.
Heated seats. All right. So different like features that may be beneficial, more of a luxury good.
Color?
Color. Yeah, for sure.
Okay, so variables. Well, we didn't look at cup holders or heated seats. We did look at these ones. So like Garrett said, we were given 350,000 car observations. We had to cut it down. We also had many different variables, which we had to turn into 16 different variables based off of these factors. So we went off of American-made versus import, horsepower, which we broke up into increments of 500. So 0 to 500, 500, 1 to 1,000. Etc. Gas, which we broke into 3, which was gas, diesel, and other. Other included electric, hybrid, CNG, any other kind that would fuel a car. Registration year, we did starting in 1990 in increments of 10 years. The mileage, we started at 0 obviously, and we went up by increments of 20,000. And then the transmission, which was either automatic or manual. And lastly, whether it had been repaired or not from previous damage. So multilinear regression. The textbook definition of multilinear regression is that it attempts to model the relationship between 2 or more explanatory variables and a response variable by fitting a linear equation to observed data. Every value of the independent variable x is associated with the value of the dependent variable y. So basically what that means is you have 2 variables, the dependent variable, which is y, and the independent variable, which is x. You put one column of data into the y variable, and you can put one or multiple into the x variable. Then the x variable essentially determines the predicted y value with the coefficients that the regression produces. So then you can then create a formula and a user-friendly model if the end user or the person is trying to find just the end number and not necessarily how it works.
So, some things of importance and to realize when looking at our model. First is the R-squared value. The R-squared value is the correlation that the X has on the price of these used cars. A good R-squared is anything above 0.2 in the business world, and as you'll see later in our model, we have a 0.31. So these coefficients then are the variables that we spoke of before, as Joe just mentioned. And these coefficients, the larger their number is, positive or negative, the more pull they have on the price. So when a car has 1,000 miles, it's not a very big pull because 1,000 miles is basically brand new. Whereas if a car has 100,000 miles, then that's a larger pull because not many people are going to want to buy a car with 100,000 miles due to the fact that it's not going to last overly long after that. So those positive and negative numbers with these coefficients, the larger they are, the more pull they have on the price. Then another thing to notice is the p-value. And the p-value, anything under a 0.05 in the business world is considered a good p-value, and we have a 0.001. So saying that with the R-squared, our model is very suitable for this prediction. And lastly, the thing to notice is binary code. So our data set originally consisted of both numbers and words. So we had types of cars, so car, suburban, SUV, bus, limousine. We had to make all of those things into a binary code, and binary means ones or zeros. So we had to do a bunch of different things to create those ones or zeros and make those words into numbers in order to run our linear regression, and Sean will show you how we did this through our Excel file.
So as Garrett was mentioning, the binary code, a lot of this, it looks very simple, putting ones and zeros. However, it's not that simple. You have to use a lot of different functions like if functions and putting it in, but the thing is it can't just be, say your example was 1991, you wanted a car that was in 1991. I can't just put, if it says it's in 1991, put 1 or put a 0. Because what if it's a 92, 93, 98, anything like that, it just comes out as bad data. So you have to do it per each year, which is why we had to separate it into 1990, 2000, 2001, 2010, separate into categories. So you're able to do that. And then, as he also mentioned, was the R-square and the p-value right here, highlighted in yellow. Those are pretty much what show how strong your model is, how well it's going to work, and how efficient it is, and if it's accurate. A lot of companies will look into these and pretty much predict whether or not you're going to be right. And then, along with that, so this is our actual model here itself. So these are different variables that we looked into. So the binary code we'll be putting in here, and then it'll tell you exactly how much pull it has, and the coefficient is here. So like Garrett was saying, 1990 to 2000, the older the car is, it's going to have a heavy pull as opposed to a 2011 to 2017 car. So to be honest, we don't really want to stay up here and just present to you guys all day. We want to get you guys involved a little bit. So if you don't mind, we're going to ask a few of you to participate and give us some numbers that are maybe your car or a car that you know of, and we'll see how much it's worth.
So who has a car that they would like to see how much it is worth? Jared?
2016, automatic, 1,000 horsepower, miles 8,700, gas foreign, and there's no damage.
What was the horsepower?
1,000.
How many miles?
8,700.
Regular gasoline?
Yep,
No damage?
no damage.
So your car would essentially be worth $7,510 and 81 cents if you want to get technical.
So who here would be interested in buying that car for that price based off of those variables?
It's got 1,000 horsepower on that.
Is there anyone that wouldn't buy that car? No one? Yeah, it's a pretty decent car. I mean, it's new. Anything that's new and doesn't have that many miles on it's going to be pretty much good for that model. So let's have another example. Anyone?
Just Scott?
Sure. It's 2013 automatic,
I'll go.
about 270 horsepower.
with 74,000 miles. Regular gas, American, no damage.
Yep, 2 miles still in there. As well. Or, no, I'm sorry.
So regular gasoline, American made.
No damage.
No damage.
I'm assuming it's your truck.
You got it.
Your truck is essentially worth $8,087. I know that probably hurt a little bit, didn't it? All right, we'll go for one more. Anyone else?
Nate? Yeah. 2005 automatic 850 horsepower with 63,000 miles on it. It's normal gas, no damage, and it's American made.
Your car is worth a little less, $3,822. So, like we said, a lot of this has to do with specifically when it was registered is probably one of the bigger coefficients that we were able to pull. Along with that, the mileage, as we stated earlier. So a lot of different variables go into this. Obviously, there's different variables like the style of car, the type of car. However, being able to put that into a multilinear regression model is kind of hard, and based off of pure data, it's a little easier to look at the numbers. So our model is relatively accurate, and that's our model. At this point, we would like to open up to any questions you guys may have.
Can you discuss how you collected the data?
The data itself, we were given from you sent us a Kaggle website data link, and it's pretty much a website that has a bunch of different data sets on it. And we were given it from there. They actually gave us too much information. We had, I think it was 3 data sets on there on its own, one of which was a coding that we would have had to put into. However, to do what we wanted to do, all we needed was 1 data set, which, like we said earlier, was 350,000 rows.
Also, it was all in German too.
Oh yeah, we had to translate it from German, which that was fun.
And it was based on a website, right?
Correct.
People posted these prices and advertisements and cars and features.
Does American made increase or decrease the value of the car?
It looks like it
Decrease.
decreases it.
According to our model, that's what I ended up doing personally, and it irks me. But hey,
But generally not that much when you consider mileage.
yeah, as well.
The impact mileage.
Or even
Yeah.
your registration too.
Yeah.
So,
So not as much as others.
or damage, yeah.
Any other questions?
And I'm curious if you noticed or had to handle any heteroscedasticity in your model, meaning, were there different sets of cars that acted differently? Do trucks depend more on horsepower and SUVs depend more on gas mileage or transmission or anything like that? Did you notice any trends among the data set?
From ours, we didn't really notice too much with that. That is definitely something I kind of looked into when I was specifically making the binary conversion. I wanted to kind of look to see if there was any maybe trends with it. Not that I noticed, but with the time we were given, noticing that as opposed to making the model. I mean, don't get me wrong, I would love to look more into that. I think there probably is a trend, and I would like to look into that as well. But we did not get a chance to.
I'd say the one thing that really popped up within our data set was that there was cars being sold for either like $0 or $1, so maybe it's like a family member giving it to a younger family member. So that's the stuff that we really saw within our data set that we had to kind of quarantine out, because that's not realistic of a used car in a resale market for, say, on something like Craigslist. Nobody's selling a car for $0. That's a giveaway. So that's really the one thing that I would say really popped up within our data set.
We found $99 million for something.
Yeah.
I think it was like
There's
a station wagon for like $9 million.
So we really didn't want to sell something.
Yeah, so canvassing the data, you definitely had to find some of the errors in that. Took a little bit of time. Any other questions? All right, well, thank you guys for your time. We appreciate you guys listening.
No.
We did it.
This is your first one.
I got it.
Here's the answer to your question is yes.
Thanks, bud. Thank you, Glenn.
Yeah, of course.
Good
job, guys.
Thank you.
Did you guys do anything with like hybrid cars? Or?
Yeah, that was one of them, like one of the types of cars. Stuff they don't say.
Was there a correlation between foreign cars and like them being manual?
We didn't really look into that, to be completely honest with you. It wasn't something we really like had to look into to look right. But I mean, that's something, yeah, we could for sure look into. But for like that question, I just didn't look into that. But that is a good question.
And I was gonna ask like, what were the future classes? Like, if you wanted to
Catch my joke?
They were in there, but we just figured like most people these days aren't driving stuff from like the 67s. Like, yeah, you can, but like we try to make it more like up to date. So we were figuring like more people are driving anything from 1990 to 2017. But yeah, they were in there. They were, and we kind of were like they're